So we're thinking about this again, and we're thinking about 3x. We're thinking 3x over 1. And if you look down here, here's the adjacent side 3x, and here's the hypotenuse 1. And then we can find the opposite side if we need to, okay? So that part we're used to. The 3x kind of presents a little trouble because if you remember the graph of arc cosine, it has a domain of 1 to -1, so normally we'd say 1, and we'd say it goes over here to -1. And, up here it's pi, when down here is 0. So it has a limit over here and over here. And the domain is from -1 to 1. But if we say 3x, then we got to go from 0 to, well, we can say 0 to 1 over 3 because we can't go past. If we say 3x, the most we could let x be is 1/3 because anything more would go past where we're allowed to go. And we're not talking about negative things. So that's what we're going to look at down here. And we will say this is really x over 1. So we build a did they tell us the limits here? Okay, as demonstrated in the example. Example 7? That's not example 7, but I think we'll be okay. So we're going to say the opposite side is x, and the adjacent is 1. So therefore, if I'm finding the hypotenuse, it's going to be c squared is equal to x squared plus 1 squared. So c would be equal to x squared plus 1 square root. So that's my hypotenuse. I'd say the square root of x squared plus 1. And now when I go to, you know what, I didn't need to do that. I didn't need to do that. Because when I look for the cotangent, I don't care about the hypotenuse. So I kind of did a little extra work there that I didn't really need to do. The cotangent is this over this. Okay, fine. So I wasted a little effort. But the answer is 1 over x. Okay. So at least I think you'll need to do that for yours. So that'll be helpful.